So welcome everyone to the Ask Me Anything Data session from AllCloud and AWS. This session, and we'll go through the speakers in just a moment, but this session is basically a chance for anyone who had any questions about AI, machine learning, IoT, anything data, to ask questions and to have the AllCloud and AWS experts answer those questions. So let's just jump right into it. Slide, please. This is our agenda for today, so I'm just going to review AllCloud very, very quickly in one slide. Jump into questions on machine learning models, on data lakes, on BI and analytics, on IoT, on AI, and then we have a few more general questions, so we can go into those. This is supposed to be an informal session, so while we did ask people to send in questions in advance, just so we can see what people were interested in and get an idea of what kind of questions people wanted answers to, we do encourage you to speak up and ask questions as we go through the different subjects. And our experts are here to answer any question you have. So slide, please. Right, so maybe I'll just present myself really quickly before getting into the experts. My name is Talia Schmidt, and I head up marketing for AllCloud in EMEA. AllCloud is a cloud service provider. We have 7 global operating centers in Tel Aviv, 2 in Germany, in Berlin, and in Munich, and then we have a few locations in the northern North America region. So that would be New York, San Francisco. We have offices in Toronto, and we have, of course, offices in Bucharest. And we're hosting AWS expert Gilly Nahum here today. So he'll talk about AWS and how they contribute in a little bit. Slide, please. AllCloud is an AWS Premier Partner certified with over 150 AWS certificates. We're part of the MSP program. We have 5 different competencies in SaaS and security and DevOps and migrations, and we're part of the MSP Partner program, so really deep expertise. And what we're here to talk about today is data and what we do with data for our clients and answering questions. So slide, please. Just a very quick view of some of the clients that AllCloud works with across the regions. Very strong logos here. So I think that just about covers that. And I think we're ready to jump into it. I mean, actually, Ruud, can we go back to the experts and maybe we'll present the experts really quickly? Because I think we may have missed that. Perfect, thank you. So let me start with introducing right to left, Jonathan Chemama, who is the AllCloud data scientist, Oshik Avioz, who is the Chief Technology Data and AI at AllCloud, and their teammates Menachem Geva, he's a Senior Data Engineer at AllCloud, and then of course from the AWS expert side we have Gilly Nahum, is a solution architect and an AI ML specialist. So guys, maybe you want to, what is a data lake and why do you need a data lake?
Yeah, so actually, data lake have become, the cornerstone for many big data activities. So just they offer a easy and more flexible option to scale when working with high volume of data that's been generated, let's say at high velocity, with a lot of variety of applications such as web sensor, app activity data, IoT device, etc. So since this type of data source have become increasingly prevalent interested in the data lake, it has become growing at a rapid pace. So the data lake is an approach of often defined to be a big data architecture that focus on storing unstructured or semi-structured and also structures data. Okay, so in a single repository, so which you can collect all this kind of data on one repository that serve a multiple analytics use case or services. So the storage and the compute resources are decoupled, so you don't that data at rest rate, for example, with expensive object store. For example, if you have a Hadoop deployment, you have the capabilities of decouple the compute and storage, and then put your storage on cheaper storage solution and put your compute on the proper compute node and the amount of node on the appropriate scale that you as organization are working on. So in AWS, you have an option of to work the storage like at Amazon S3, which is give you a lot of variety of tools and services that you can connect to Amazon S3, like Amazon Athena, Elasticsearch, Amazon EMR, and a lot of Glue, so which is a kind of serverless solution that allow you to catalog your data, to running ETL job on top of this data.
Mm-hmm.
So this is actually different from traditional database or data warehouse architecture. So the compute and store are coupled in the say. So the data is structures, and you can do some analyze and store data in very cheap and very rapidly solution. So in case you want to consume from the data lake data which be relevant for machine learning training data. So maybe you need some data from the data lake which is going through to the data warehouse for the analytics aspect. Maybe you need from the data lake some a data streaming that coming from a IoT device or from applications that come from the website or mobile application, and you need this data for real-time analytics. So the thing is that you can store all this data in the data lake, and then you can do a lot of analysis under this data in the future. If I going to the business aspects, so actually the organization successfully generate business value from their data. So there, have a survey that organization who implemented data lakes, similar companies they can decrease by 9% in the organic revenue growth. So which is a lot of money for saving money actually. I think that's it for now. I don't want to get deep dive to the technical. So if I summarize, so why we need data lakes? So data lakes is allow you a central data repository to support in all your data organization, whatever the format is, whatever the size is, and whatever the volume is.
Okay, sounds good.
Application. Yeah, I'm here. Let's start with the question. So there were a lot of interesting questions that were asked. I think that the first one that was really probably one of the most interesting, it's how to implement a machine learning model into production. So putting a machine learning model into production is really a hot question, and a lot of people are asking themselves, how do you do that? How do you actually put it into production? Because that's for over a few years, for over a lot of years actually, machine learning was something that was stuck in labs. It was a research subject, and it was really difficult to take it into production. And over the last few years, we have seen a lot of tools appear that made it a lot easier. So before I speak about a few tools, I just want to talk about a few questions you need to ask yourself when you want to put your model into production. The first thing, it might seem a bit trivial, but the first thing you have to ask yourself is, do you want to make predictions real time, or do you want to make batch predictions? A lot of predictions over, for instance, over a night or over a few days. Do you need real time or not? And obviously, this question has a lot of ramifications. It has a lot of implications in terms of the infrastructure you're going to choose, about how much our architecture is going to cost. There are lots and lots of considerations. Obviously, when you're real time, you have a very high operational responsibility. When it's batch, you have a lot less responsibility. When it's real time, you have to be able to handle peak load, whereas batch, no, you can just spread the prediction computing power throughout the day. So a lot of considerations around that, and it might seem trivial, but a lot of our customers come to us and they don't have the answers to these questions. And they need our help to go through the journey and to define a real use case and the real right architecture. So that's really a first question you have to ask yourself. Then, I mean, the two main points I wanted to tackle is once you have a model in production, once you have a model that is live, that is running, you really have to monitor it. You cannot just say, okay, I have a model, I put it online, and now it's working fine. No, it doesn't work like that. You have to monitor it constantly for a very simple reason. It's called data drift. And what it means is that your model with time will see its accuracy decrease. And there are lots of reasons for that, but a very simple reason: you train your model today with data maybe from the last 6 months. And in 2 years from now, your model will have been trained on data that is 2.5 years old. So obviously your data is now outdated. Obviously the world has changed. You need to retrain your model. You need to monitor your model to check if its accuracy decreases over time or not. It will decrease, spoiler alert. And when you see it decrease, then you have to retrain it. So you have to have a procedure in place. And it's almost, like what I'm describing right now is almost part of a CI/CD pipeline. CI/CD for machine learning is a bit different than CI/CD for a classic web application, because you have also to consider the data. But let's only focus on the model here. So once you have something in place to monitor your model, you have to decide when to retrain it. So you have to analyze its performance. You have to decide how often you want to retrain it. And then you have to implement something to be able to retrain it easily and to repush it online easily. So very interestingly, a lot of tools very recently have been developed, most notably by AWS, to help with model monitoring and with model retraining. If you can go to the next slide. So maybe, I don't know, Gili, if you want to add a few words on that. But if you can see, these are a lot of services by AWS to help people develop a machine learning model and to deploy it. And you can see on the right side, you have the services that help deploy and manage a machine learning model. I won't talk about all of them, but you can see Model Monitor, Amazon SageMaker Model Monitor on the right side. So SageMaker, it's maybe actually nobody, some people might not know what SageMaker is. SageMaker is the place where all your machine learning model, all your machine learning is going to happen on AWS. You can do everything machine learning on SageMaker, from labeling to deploying. And so Model Monitor is one of the very few, one of the very recent services that AWS released that helps monitor your model, like the word indicates, and decides when to redeploy and when to retrain and when to redeploy. So you have a lot of services, like I said, who have been released recently, and it's really worth exploring. So really, if I want to sum up, you have, like I said, there are lots of considerations when you want to deploy your model, but the two main ones is how are you going to monitor it and how are you going to retrain it for a new deployment.
Okay, makes sense. We do have one more question that came up, Constantine, during what you were saying about the machine learning. So maybe we just jump into that. And Constantine's question is, which tools do you use, or if you don't use, at least could you recommend for one, ML models entire lifecycle management, and then the second is scheduling data pipelines, of course, both in AWS, in an AWS environment? Sure.
So, like I said, maybe it's the chance to dive a bit deeper into SageMaker. It's the tool we use mainly at AllCloud with our clients. it really allows you to deal with every part of a machine learning model development.
Someone's calling you, Jonathan.
You have a lot of phones. Anyway, so the first part in when you deploy a machine learning, when you develop a machine learning model, is you have to label your data. SageMaker gives you the opportunity to do that with a ground truth. It's a really great tool. Objectively, I think it's one of the best tools around to label your data. Then you have to develop a model proper. You have to code, and you have notebook instances that are ready with all the frameworks, with all the most popular frameworks to develop a model. And you can also use the AWS built-in algorithm to train. Once you have your data labeled and your algorithm, you train it, and you can optimize it. You can tune it with hyperparameter tuning jobs, which are all managed on SageMaker. And then you can deploy your model either to a hosting instance, so you can deploy it live, or you can integrate with IoT and you can deploy it with Greengrass. You can deploy it on an IoT device. So on a very high level, that's the flow with SageMaker. And scheduling data pipeline, I mean, you have a lot. I don't really know what Konstantin means by that. You have a lot of different tools to integrate with. So I don't know, maybe Gili wants to add a word, or Menachem, I don't know, on that.
I think Menachem is having connectivity issues. So, Gili, do you maybe want to talk?
Yeah. So it really depends on, as Jonathan said, there's a lot of options, and it really depends on what's your already existing. Usually customers would go with their existing data pipeline if they have one. So if, for example, some customers use maybe Airflow to run all sorts of tasks to pre-process the data, and then after that you could use SageMaker to train the data, and then after that you could do some post-processing, and then also even deploy the data to SageMaker endpoint, so deploy the model. Other customers, so for example, the native AWS workflow management that we provide is a step function. It's a serverless orchestrator that allows you to run all sorts of jobs, and it's also fully integrates with SageMaker, so you don't need to write code in order to build your pipeline. That's one option. And step function also have a Python SDK that allows data scientists to build their own pipeline. That's another option. Other customers are more used to work with Spark, and then we have integrations from Spark directly to SageMaker. So there are classes that extend Spark ML, which allows you to run from SageMaker. Also, if you use Airflow, there are operators for Airflow that allows you to call SageMaker. So almost with all of the different pipelines out there, they have connectivity to SageMaker. Konstantin, I can see you're typing, so if there will be a follow-up question, we can also answer that. But generally, this is what I see being used for data pipelines.
Okay, perfect.
I can also, so I see the follow-up question. So you're asking Konstantin SageMaker, but also MLflow and DVC. So this can be used on premise. Yeah, so I think that MLflow as a third-party framework has an option to deploy to SageMaker. So some customers use that. SageMaker, in general, it's a platform, and you can use just the parts that you like. You can, for example, use only hosted Jupyter notebooks, or you could just use the deployment part, or just the training part, or just the annotation, or some of them, any combination that makes sense for you. DVC, so some customers use DVC on top of S3. For anyone that doesn't know, DVC is a way to manage versions of your data, and in a conservative, by conserving space, also works on top of S3, so customers use that. SageMaker currently doesn't provide a way to kind of version your data beyond just running, copying, having a dedicated folder in S3 for each training job. Beyond that, you'll need to use DVC. So some customers use DVC, take the DVC version, put it into their GitHub, and then they commit a GitHub. They do a Git commit, and then they take the Git commit ID and tag the SageMaker training job with that ID. So whenever they want to reproduce an experiment, they can take the training job ID. They can go to the training job, find the Git commit ID, clone from Git, and then see the DVC ID and do the matching DVC action to bring back the relevant files, and then they can reproduce the experiment. So that's my answer. Back to you, Talia.
Okay. I think that was clear. Thank you for that detailed answer. Let's move on to AI services questions. So with the growing productization of ML off-the-shelf service and the pre-made generic models of common business needs, how do you picture the role of a data scientist 5 years from now? So I think this would be good for you, Jonathan. How do you see the role of a data scientist 5 years from now?
Yes, so it's actually a very interesting question, and most people in the industry are asking themselves if a data scientist will still be relevant in 5 years. You can see that AI applications are getting so sophisticated that actually part of the work of a data scientist can now be made by an AI application. So it's really legitimate to ask yourself if in 5 years, in a few years, let's say, data scientists will still be useful. I think it's always very difficult to predict the future, but I think that, yes, most data scientists of today will see their jobs evolve significantly in the next few years. And most of what they do today, they won't do in 5 years. If you want to switch to the next slide, I tried to sum up, I think, the 3 directions towards which the role of a data scientist will go to. I think you will still have very technical research roles for data scientists, working on very sophisticated and custom algorithms, which you cannot buy off the shelf, or you cannot use for applications for which you cannot use built-in algorithms. I think this will be mainly research roles, and probably only in very big tech companies like AWS, like Microsoft. It will be in the research labs. That's one role. I think the other one will be more of a management roles, a lot less technical, even less technical, let's say, than now. And I think these kind of roles would have been previously filled by MBAs, when a lot of people said companies needed business acumen. I think now companies realize they need more data acumen. I don't know if I coined this term or not. Companies are getting a lot more data-driven now, and they really need at every level, not only in AI, they need at every level, they need people who are competent in data, who think data, So I think for these data scientists, I think the skills they need to develop would be soft skills. They're going to need team management skills, they're going to need communication skills, they're going to need even business understanding, and a bit less technical skills. So I think that's another directions that data scientists can take. And I think the third one will be MLOps. So, MLOps is a term that is very similar to DevOps, but for ML. So the role of the MLOps is to coordinate between the data analysts, the data engineers, the DevOps, and all the operation professionals. So to coordinate between all these people to make sure to allow for the machine learning model to be deployed. It's a really fascinating field right now, and it's really booming. And I think data scientists will have a big role to play in this field. So I think these are the three main roles data scientists will occupy in 5 years. I might be a bit pessimistic, but I don't think data scientists that develops a basic machine learning model today will be needed in a few years.
I think I agree. I think that especially for marketing roles, if you say management roles were previously filled by MBAs, but now companies are looking for people who do have data acumen. I think that's very, very clear in marketing roles. So if marketing used to be a lot of advertising, a lot of creative, I think that over the last few years, especially over the last couple of years, we've seen a shift into more data-driven models for marketing, predicting behavior, predicting customer behavior, especially for more product-oriented companies. I think data is very, very big.
Yeah, no, definitely. Like I said, you can't have just one layer of a company that understands data. Now you have to.
Right.
So yeah, I think that's.
Yeah. Mm-hmm. Okay, so let's move on to some of the other questions. We're about halfway in, so we don't have a lot of time, but we've already done data lakes and data warehouse at the beginning when we were waiting for everyone to figure out the tech. So let's move on and talk about BI and analytics. The question is your analytic platform designed for BI and DWH?
Data warehouse, yes.
Yeah, okay.
Okay, so let me answer this question. So actually, the BI and data analytic is a huge use, let's say, content in organizations. So I think before we are answer on this question, we need to understand why we need data and analytic in our organization. So what is for actually? So that will give us a drive, insight from your data with highly scalable and secure solution that can give you a quick insight, whether it's on real time or in the batch. You need to understand your data, you need to understand your business, and to action as much as quicker that you can for each specific data that you want to analyze. So this question actually, I think I take it to the answer like, do you want your data and analytic to be like modernized, like something that you need to know a quick insight on real time, something you need to react very, very quick, and not something that happened day before and then you react just day after. So when you're going to design your data analytic, you need to think about a few important phases in your data. So the first phase actually is the data orchestration. So how your data is organized. What is the amount of the data source and how many data sources you have, and what is the type of each data source, in order to bring a collection of data source that bring you an analytic story from all this data source together. And the second phase is the data collections. You need to take care about data collection, how you collect the data. For example, if you want to collect the data from streaming device, or this is a different data access framework configuration. If you want to collect the data from other ERP system, from file system, logs, web API, whatever, this is need to be careful for each data framework and how to configure on a secure manner, and of course for the latency. And then the third phase is data preparation. What you need to do in your preparation side. what kind of transformation you need to do. There is some specific data enrichment you need to do on your data. And then you're thinking about the data visualization phases and reporting for your analytics. What kind of dashboard you need to design, whether it is a result from time series or maybe it's from pie chart or whatever. And then, of course, you need to think about the analytic platform in the advanced analytic phase, which is what kind of analytic you would like to running on this data. Where is a data analytic you want to running on something that came from data warehouse, which is actually is a data aggregated table already. So maybe you need to queries and digest data from your data lake, which is a raw data, and you need to do a massive scan analytic on this data. So this is actually the key phase that you need to ask yourselves before you are starting to work on a data and build data analytic platform. And on AWS, give you a bunch of portfolios, AWS service that allow you to build this solution, this kind of solution. And the first one is actually bring your solution how to collect the data on the aspect of streaming solution collection, connecting device for IoT, enable to connect for your database on-premise and bring the data to the cloud and start working on it on the cloud. So there is the Kinesis family, for example, for this kind of solution, which is allow you to bring data on a streaming manner. And the aspect of transformation, you have a serverless as a function solution, which is a Lambda function that bring you a capability to do some transformation on your data, to do some analytic and some pre-processing before you send it to your warehouse or send it to your data lake. You have a glue family, as I mentioned before, which is give you a capability to run ETL data pipeline on this on your data. You can use Athena, which is a Presto as a service, and it allow you to analyze your data. But for example, on the costing aspect, you pay only for data that you're scanning. So you pay per query, not some compute node that you're setting for specific instance type, and this is what you pay for each hour. So which is very, very cheap for you. So, and also you have a Redshift data as a data warehouse as a service. It's designed to be a data warehouse, very, very, I think it's about 10 times faster than any data warehouse in the market. So you can use it also. You can use a quick site, which is a lot of visualization report and analytics that you can use this with also machine learning capabilities. And you can using an EMR, which is Elastic MapReduce, which is Hadoop as a service, which allow you to do some processing your data on a distribution manner, so you can collect data, process, and bring into a different format. And of course, with a capability to running with amount of data, with hexabyte of data, and a lot of that. So this is the key top AWS service that you can use on AWS to build a analytic platform, to build a BI platform, and of course, to build a modern data warehouse on AWS. Back to you, Talia.
Okay, perfect. Thank you for such a detailed answer, Oshik. I think that was a good kind of, that dovetails kind of to the previous event that we did on analytics and redesigning your analytics using the data models. You remember that? That was like a month ago?
Yeah, sure.
Yeah. Okay.
Yeah.
So what does AWS IoT Core offer?
Okay, so AWS IoT is a whole platform to develop IoT applications, and it includes the AWS IoT Core, and it also includes other modules like IoT Analytics, which allows you to easily integrate with doing analytics on your data that is coming from IoT Core, store it, and run analytics over it. And if we want to focus specifically on IoT Core, it's a managed service, and it lets connected devices easily and securely interact with the cloud application and other AWS services. So when you want to deploy devices out there on the field, you need to take care of several concerns. First, you need to securely connect the devices to the cloud. Then you need to have some way to route the different messages that are incoming and take actions on those incoming messages from the devices. And you need to enable applications to interact with the devices even if the devices are offline, so that the logic that you build is doesn't need to take offline into account. It's automatically handled by the service. And you also need to integrate with other AWS services, analytics, databases, AI, in an easy way. And IoT Core does that. So it provides authentication of devices and provisioning. It provides a device gateway, which is a fully managed connectivity. It takes care of, for example, it takes care of doing the live, so heartbeats, keeping the devices online, connecting. If there are millions of devices, it auto scales. There's also a message broker that allows you to talk MQTT or HTTP from the devices. There's a rule engine which allows you to configure different rules, visualize them, run reports over that. There's a service called Device Shadow that allows you to write to a device which is currently offline, and then when the device comes back offline, the data replicates. And this works both ways. So the device can also write to the shadow, and once there's a cloud connectivity is restored, the shadow data is automatically copied to the cloud. And there's also a registry that keeps track of all of the connected devices. And it's basically a catalog. You can also, for example, you can run SQL-like queries over all of your devices. For example, give me all of the devices deployed in Germany, which are running version 2 and didn't connect in the last 14 days. All sorts of different queries. It all comes out of the box. This is basically what IoT Core takes care of and can provide.
Okay, interesting. Good, thank you. All right, so we just have 2 more questions, I think, that kind of fall under the everything else section. So why don't we go into that, and I think we'll have just enough time to cover this and wrap up. Yeah. Okay, so let's do the second question. What's the recommendation for the correct use of data in relation to customer experience? And I guess this is pretty business oriented and kind of wide, so feel free to take this any way you want.
Okay. So it really depends on. It's a very broad question. I can maybe give a broad answer. So first of all, you might be in a business that have regulations. So you need to adhere to the European GDPR. So the customer experience here would be that they can approach you and ask you to, for example, delete all of their data. So when you are saving the data and operating with it, you need to take that into account. And we have different services that can help do that, plus general guidance. The customer experience might be latency related. So customers expect to see real-time data. They don't want to see what happened last week or last day. They want to see what happened in the last 5 minutes. So in here too, there are different architecture which you can apply in AWS. For example, the Lambda architecture, not to be confused with the serverless Lambda. The Lambda architecture also, you could call it a batch layer and a speed layer. So you can have incoming data, and then the data comes into something like Amazon Kinesis, which is a service that knows how to deal with streaming data. And from there, it can go to it can split up. One it would go first to a Kinesis firehose, and Kinesis firehose would save it in S3. And then once it's in S3, it can be queried. But if you want actual real-time data, you can push it into Kinesis streams that handles real-time data. And from there, you could run a Lambda that would process the event and take actions. Or if you want more analytics, kind of real-time analytics, then you can use Kinesis Analytics, which allows you to run SQL on top of time windows. So you could, for example, ask what is the average click-through rate in the last 10 minutes, in the last 5 minutes, and show all of these values in a dashboard.
Mm-hmm.
Correct use of, let's think about just one more example, correct use of data in relation to customer experience. So there were some cases in Israel lately where there was cyber attacks on sites that host companies' websites. And at one incident, I think they weren't able, or it took them so much time to restore the customer's website. So in that respect, they weren't backupping their data correctly. And for that matter, we have a lot of ways to back up your data, make sure it can't be deleted, even if an attacker managed to get through your system through some applicative loophole. And I guess if someone really wants to dive deeper into how to deal with data in the right way, technically we have a series of white papers which are called AWS Well Architected, and then you could search for AWS Well Architected white papers, and it focuses on several aspects, including resiliency, including security, and I would advise to go there and see if it addresses additional questions.
Okay, great. So that's a resource reference to anyone who wants to learn more. So that's really great, and thank you for that. And I think with that we can wrap it up, unless we want to take. Does anyone have any further questions from the audience? All right, I guess Konstantin's was the last one. So I think we can wrap it up here. Thank you, everyone, for joining today. And thank you for your expertise and being so patient and answering everyone's questions. I think you all gave really great, detailed answers. We will follow up with the link to the recording of this, so you can go back and listen. And feel free to contact us at AllCloud and ask more questions, and then we will make sure that they land on the right desk. So thank you again, everyone.
Thanks.
Thank you.
Bye. Bye.
Bye-bye.